This is the Chapter 3 test review. What does a correlation close to 0 indicate? If we have a correlation or an R value that is close to 0, this indicates a scatter plot that does not have a linear pattern. The points have no pattern and are all scattered around the plot. There is a linear relationship between the number of chirps made by a striped ground cricket and the air temperature. A least squares fit of some data collected by a biologist is given in this model, where x is the number of chirps per minute and y hat is the estimated temperature in degrees Fahrenheit. What is the estimated increase in temperature that corresponds to an increase of 3 chirps per minute? So we need to find two different x values that increase by 3. Now, if you notice, our equation only works when x is between 9 and 9 and 25. So if we find our y hat for when x is 10, and we need to find it for 3 more than that, which will be 13, we can then find the difference between those two values. And we would expect an increase in 9.9 chirps per minute when the degree is increased by 3. The equation of the least squares regression line for the points on a scatter plot is given below. What is the residual for the point at 6, 8? So to find this, we need to find what our predicted value when x is 6, and we're going to get an expected value of 5.68. To find the residual, we do the observed minus the predicted. So in this case, we observed a value of 8, we predicted a value of 5.68, which means our residual would be 2.32. The slope of the least squares regression line is 0.8, and the correlation R is 0.73. What can be said about the standard deviation of the explanatory and response variables? Now, if you remember, slope is R times the standard deviation of y over the standard deviation of x. So if we know that the slope is 0.8 and we know that the correlation is 0.5, we can find some information out about the standard deviations. Right now we have multiplication, so the opposite of that is division. And we're going to get 1.06 repeating is equal to the standard deviation of y over the standard deviation of x. Since when you divide the standard deviation of y over the standard deviation of x and we get a value that is greater than 1, we know that the standard deviation of y must be larger than the standard deviation of x. What do we know to be true about correlation or the R value? Correlation measures the direction and the strength of a linear relationship between two quantitative variables. The correlation R is always somewhere between -1 and +1. And if your correlation is negative, that means the slope of your least squares regression line will be negative. And if your correlation is positive, the slope of your least squares regression line will be positive. Interpret the following value. S is equal to 3.45. This means, on average, the predictions made by our least squares line will be off by 3.45 units. we need to write the equation of the least squares line. Now again, we know that slope is equal to r times s sub y over s sub x, or in this case, it would be 0.85 times 5.4 over 1.2, which is going to give us a slope of negative 3.825. To find our a value, we're going to do the mean of the y's minus b times the mean of the x's. And if we put that all into your calculator, you're going to get an a value of 58.29625. So once you have your a and your b, to write your equation, it's just a minus bx, a plus bx. So we take our a value and we add our b value. Since it is a negative, we can write that as minus 3.825x. If the outlier in red were to be removed, what effect would this have on the slope of the regression line and the y-intercept? If we were to remove this point up here, that red star, that's not going to pull the line up as much. If you notice, all the rest of the points are down here. So our least squares regression will probably cut through those points. So if you notice, the slope of our line was here. Our slope was much steeper than what we ended up with, so the slope would decrease, but our y-intercept was down here. It is now moved up here, so the y-intercept will increase. Describe the nature of the association between time and percent received. So there is a moderately strong positive curved association, because our points go this way, between study time and the percent received. Some data were collected on the weight of female babies for the first several months of their life. So the first thing we need to do is create a scatter plot and display the data and label it. So remember, when you create a scatter plot, you need to label. And then you would create your scatter plot. From there, you're going to use this to calculate your least squares regression line. Remember, you can do this on your calculator. You would hit Stat, go over to Calculate, and you would go down and select the linear regression a plus bx. Yeah, I'm making a video. So we got our least squares regression line to be y hat is equal to 3.91 plus 0.50x. Now we can take this equation and we can use this to predict a baby's weight at 9 months, since it is not given in our table. So we would take our 9 and plug it in for our x value. And if we solve this, we're going to get 8.4176 kilograms. So we would expect that baby at 9 months to weigh 8.4 kilograms. Now we need to predict the baby's weight at 3 years. And is it appropriate to use this equation to make a prediction? So 3 years is the same thing as 36 months. So if we plug this in, we're going to get 21.93 kilograms, or approximately 48 pounds. Now, it is not reasonable to think a baby is going to keep increasing its height and weight at the same rate it was during the first year of its life. So this is an extrapolation. It is well past the data point that we have because our last data point is 12 months. So it is not appropriate to use this equation to make a prediction for a child at 3 years. Identify the unusual point on the scatter plot. Why is it unusual? So on the unusual point in this case would be this point down here. It's unusual because it does not fit the pattern of as x increases, y increases as well. If this point were removed, describe the effects on the correlation, the slope, and the y-intercept. So because this point is so far away from that line, it is making the correlation smaller. If we were to remove that point, our line would most likely come this direction through those points. Now we can see all those points are much closer to the line, so the correlation would increase. The slope of our line is steeper now, so the slope would increase, and our intercept went from intercepting up here at the red down to the green, so the y-intercept would decrease. How well does the number of beers a person drinks predict his or her blood alcohol content? 16 volunteers with an initial blood alcohol content of 0 drank a randomly assigned number of cans of beer. 30 minutes later, a police officer measured their blood alcohol content. Least squares regression was performed on the data. Some computer output for the regression are shown below. So given all this information, we need to write an equation of the least squares regression line and be sure to define any variables that you use. Now, we have the coefficients. The constant is your A value, and the one, because we're changing the number of beers, we know that that is your slope or your B value. So we can say our predicted blood alcohol content is equal to negative 0.012701 plus 0.017964 times the number of beers. Now, if you just want to write this with y's and x's, you would just write y hat is equal to and put an x at the end, but then you would have to define that x equals the number of beers and y is the blood alcohol content. Explain what the slope of the regression line means in this setting. Now remember, this was our slope, so this tells us that we predict for every increase or every additional beer a person drinks, we expect their blood alcohol content to increase by 0.017964. Find the correlation, interpret its value in context. So right now we know that the R squared value is 80% or 0.80. To find the R value, we're going to take the square root of both sides. But remember, when you take the square root, it is positive or negative. Now remember, there's a relationship between the slope and the R value. If the slope is positive, then the R value is also positive. And if we interpret this in context, this means that we do have a positive correlation, and it would be moderately strong linear correlation. Is a linear model appropriate for describing the relationship between the number of beers consumed and the blood alcohol content? Support your answer. So we know that the R squared value is 80%. So we know that 80% of the variation in the blood alcohol content is accounted for by the regression line. But we do expect that our prediction will be off by 0.02. Since the legal limit for blood alcohol content in driving is 0.08 and 0.02 is a quarter of that, this may not be an appropriate equation to use in support of our claim.